And in this video, we're going to be looking at another very popular interview question called this one is known as count and say. Now, accountancy is it's a very interesting problem. It falls under string because sometimes you're supplied basically you're asked to process string, but you can actually solve this using integer as well. Now, or int array basically. So because it's easier to explain the processing, like how accountancy works in integer, you can very well opt to go and solve it using integer and then convert that integer into string at the end because like that then string interpolation is rather easy otherwise you'd have to do actually at every step. So by the way, don't get me wrong, you can do it with string as well. It's just it's easier to explain, and while you're at the interview what you're looking for is an efficient solution, but in a solution that you can actually formulate the algorithm rather quickly. So I found that basically formulating algorithm with numbers is rather easier because you can think logically in those sense. So that said, here's the problem. So the problem is you're given an input, okay, and in for that input you just, for example, you just have one. Now, how would you count this one? You're gonna say there's one one. Okay, so the output becomes one one, and the output that actually comes out of saying this particular number becomes the input for the next iteration. Okay, and what the interviewer is gonna ask you is to give me like what's gonna be the fifth reading or the fifth um, uh, fifth sequence for content say. So you can actually do first sequence is one, second sequence is there's one one, so there are two ones here. Now you're gonna say two one, so two one, that becomes your output. Now here you say one two one one, so one two one one. So that's how you actually uh, build your output, and then that output becomes input until you reach that count that you need, fifth sequence, right? So here you're gonna say one 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 two two one, right? So one 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 two two one. So that's gonna be your final output. Okay. So take a moment to understand, how this problem actually works, or how this problem actually looks and operate, and then give it a try. Just to give you a hint, uh, basically this particular problem you can solve using the only solution that's available is using n squared, that I know of. Just so you know, don't try to solve it all of n times first. Uh, Come up with a solution and think about it, how you would go and solve it. With looping and some conditional checking, you should be able to achieve the result. Okay, so pause the video here and take a stab at it, and then unpause to see what we have got as a solution for you. I hope that went well. So let's take a look at the solution. So, like I said, the main idea is to basically loop and do some conditional checking. So what we're gonna do is we're gonna first make the first input. That's the main idea. The first input is going to be the input for next iteration. So whatever the input comes out, it's going to be the iteration. So we're going to seed uh, our loop with one, and that is going to give us output as one one. That becomes one one becomes the input for next iteration, and we repeat it until the count or the sequence that we need to reach, the count of the sequence is met. Now, another thing to keep in mind that you need to count until the matching element is found, and then append that matching element. So you keep a counter for let's say one one. So when you found one, you say one current element is one, and the count for it is one. And when you find another one in next iteration, you say, okay, current element and the currently iterated element is also one, so that means I need to increase the count. Now, eventually, when your loop ends, at the end, you're gonna append, you're gonna create your result. You're gonna say, I found two ones, so append the count first, and then the actual number that's been counted, right? So that's how you actually build the solution. So it's a little bit easier if we take a look at the algorithm first, and then we're gonna walk through the example. So the algorithm, the way it's gonna go is we're gonna start from say. I just named these functions, and we've given an integer, like number of times the sequence is gonna repeat, and we can say, okay, seed this result with one and iterate over or loop n times. Okay, so then for each time you loop over, call this function loop, and whatever its output is, replace it with the result. So that's what we are talking about, like making output as the input for next iteration, and go on and do the next iteration, and eventually return the last result that you get. Okay, so the way it goes is basically you first get your sequence, basically create like a temporary array, Swift thing. Then you get your current first element, okay, and current element as your first element, and then you create a variable called counter, and basically assign it as one, okay, because you're gonna count. So you're gonna count the matching item, okay. Then we're gonna remove first item because we already have this in current, so we can start our loop from the next item in the array, okay. And then we create the result to basically keep the track of results, and then we do go in the for loop. Now in the for loop, we go iterate over each item, and we say if the current item, right, the current that we have actually cached is equal to the currently iterated item I, right, then increase the count and go on to next iteration. When when you're gonna have a 1 1, it's gonna be counted as two, and then you're gonna go iterate over. Now you're for if you just had like 1 1 as input, your loop ends here. So you're gonna take your result and append count. So that's gonna be two, and the current item, which is still one, right? So that's what you actually updated. Um, I mean, that's what you had because you didn't find anything new. So you add 2 and 1 and you return that. Okay. In the next iteration, when you come back, you have uh, 2 1, right? So you say the current gets 2, count gets 1. Okay. You remove first item and you go into loop. So you say current basically is 2 is equal 1. Um, well, that's not the case. So you append 2, right? Oh, you append basically the count, basically one, and you append current, which is two, so 1 2, right? And then you assign the currently iterated item, which is I, which is one, to the current, and you assign its count to one. Okay. Um, then at the end, when the loop ends, because loop is gonna end, it's only one item, so loop is gonna end right there. So you already have 1 2 in your array. Okay, now you're gonna append another one, and for the count, because you found one, you're looking for 2 1, and then you have the current item, which is 1. So your final output becomes 1 2 1 1. Okay, it's it's a little bit confusing to follow, so let's take a look at here. Okay, so your input is 1 and 1 1. So these are just the inputs. We start with count and current as 1. So let's take this input, uh, like 1 2 2 1, because it's easier to understand. We have enough elements to actually process. So our count becomes 1, right? We initialize it 1. Current becomes the first element of the array, so we get that. Then we take the first element out, and we leave the array with 211. So current array becomes 211. Okay, result array has nothing in it. We loop over. So the current item is one, the first element that we removed. And when we are iterating over, we're saying one is equal to, right? So you have your one, that's your current item, and two, currently iterating item, right? First element. So you skip and you say result dot append one and result dot append one. So basically one for the count and one for the current element. So you append your current element, your count, and your current element. And then you update your current to become the currently iterated item 2, and you reset your counter to 1. Okay, so now your current is 2 and your count is again 1. You compare 2 is equal to 1. No, it's not. So you again append that. You say 1, 1 in the result, and you say 1, 2, right? And you update your current and your count once again. Now, at this time, your current is equal to the output 1, right? So, excuse me. Uh, that was a sneeze. Um, so 1 is equal to 1. So that means we need to increment the count to become 2. At the end of the loop, we want to append whatever the count was and the current item because last iteration didn't count that. So that's why we're going to say we're going to add 2 and 1 in the array. Okay. So I know this is like really hard to follow because it's a little bit like tricky. You're saying stuff and you're doing stuff and all that stuff. So so uh, so take a look and go over this a whole bunch of time. Trust me, it took me several attempts to actually understand the algorithm itself. Once you understand it, or once you actually build it and print yourself, some uh, uh, put some print statements here and there and see what kind of output you're getting, then you can understand. If it helps, open Xcode or IDE of your choice and put some debug points and breakpoints, and then debug this to see how it's actually working. But here is how the lab is going to look like. So let's build it in the code. So we're going to create a function internal, say content say. Okay, and this is going to take an array as input, and it's going to return an array as input. Like I said, it's easier to work with integer because then you're not talking in the mix of all these count and say and stuff. You're not adding string manipulation, which makes it hard to explain. Okay, now first thing we need to do is first we create our result array. So that's going to be empty. Then we take our current, like the first element. So whichever the first element for let's do this. First create a temp array uh, because Swift does not allow us to uh, alter the input, the parameter array, and we're gonna say current is the first element in the array. Then we say array dot remove first. Okay, so we remove the first one. Then we create our count, which is 1. Now we go in the loop for I or item in array, right? And here we check if the current is equal to item, right? So if they're equal to item, then we actually need to increment our counter by 1 because it's the same element and we need to keep counting until we reach the point where we cannot count that element anymore. Okay. If we cannot count anymore, then first thing we're gonna do is we're gonna append our count because what we append is say first. So 1, 2, right? 1, 1. So we are saying 1. How many counts of 1 is we are appending it first, right? So that's why we are appending the count first. Then you append your current next. You update your current to become the item, currently iterated item, and you update your count to be 1. Okay. Now, all this is going to end, like, when this loop ends, uh, we have uh, currently computed count and current value that we haven't added into our array. So we're going to just copy and paste this thing. So we want to make sure that we add our final count and final current element into the result as well. And then we're going to simply return that result. Okay. Now there's going to be another function that's going to call this. Like I said, it's going to be n squared, so double loop, loop inside loop, and you can say count and say, and basically this one takes how many times we need to iterate or which sequence we need, right? So here we're gonna create our result, and you're gonna seed it with one, okay? And say if n is less than equal to one, then we return. Well, if n is equal to 1, then we return result. And if n is equal to 0, is less than equal to 0, then we return empty, right? And if none of these are the cases, then we actually iterate for I n, or for underscore n, because we are not going to use I, 0 till n, okay? And we're going to take our result, and we're going to call our internal count and say with result as an input, right? So the output for internal is going to become the input for next iteration. Just to show you what we've got in the next iteration, we're going to print that result, and we're also going to return the result. Okay, so let's print count and say, and we want this to iterate 3 times, for example. Okay, let's run this. As you can see, we counted as 1, 1. So initially, when we actually gave it the input, it was only 1, 1. So we said the output was 1, 1. That became input. That counted 1 is appearing 2 times, so there are 2 ones, right? Then in the next iteration, we say 1, 2, right? So 1, 2, and 1, 1. And that becomes our final output. Okay. So if you add 4, and there you go. You have um, that newer count. So 1, 1, 1, 2. Sorry, 1, 1. So 1, 1. There's only 1, 2. So 1, 2. And there are 2 ones. So 2, 1. Okay. So and one thing you would notice that this time it took rather a long time to execute because of the n squared. So as your time complexity increases, your output, your execution time, increases. So this is a perfect example where, you're gonna see that. Well, this is the only solution that I could find, I could come up with that's actually efficient, um, in space and time complexity. So I hope you enjoyed it. I would say, once again, this is a rather tricky problem. So put some breakpoints, understand how it actually works. It's just a manipulation of some loops and conditions, and that's how you get the result. But I hope actually it explains, I did a good job, explaining you how actually this algorithm works. Okay, so thanks again for watching, and I will see you guys in the next video.